Hello everybody, this is Todd Frazee and this is the S60-105 cam tutorial for the rod end. Okay, so this is a turned end milled part. We're going to turn the outside profiles and then do the drilling and the flats. Now, when we modeled this, I led you astray and we revolved this component. But if you actually look at the drawing, the very end here, the way we model it, is spherical. Okay, so what we're going to end up doing is we're going to go ahead and turn the outside of the part, but this radius side will be just created by our profiling. Okay, now the lathe package in HSM has issues when processing off the model when you have features that are not turned. So like this isn't a full radius. We've got two steps here. So when we go to the full turning, we're going to experience problems with some of the routines because this would be an interrupted cut. So there's two approaches you can take. One, you could roll back in the history to just the revolve, and then you could do that turning. Problem is when you roll it forward to do the other things and you go to generate, you're going to get errors on those routines. The other method is you can select geometry other than the model if it's visible. And so this is why, even though on some of those ones that were models that were debatable on whether you extruded them or not, we revolved them. In that way we can use an underlying sketch for the profile. So we're going to go to, before we start, we're going to go to the sketch that we revolved, which I believe in should have been in the front view according to how we modeled it. If it isn't, it's not a big deal. But we're going to go to that and we're going to right click on it and we're going to make that sketch visible. And you want to make sure that over here on the right, I think it's default settings, but you need to have view sketches selected here. Mine was by default, so hopefully yours is. If that's not selected, it's still going to be invisible. Okay, so we're going to use part of this geometry to drive toolpath on instead of the model. Okay, so we're going to, now let's go and tab over to cam. And it's important we display this sketch first because the axis orientation is going to need to be in the same plane as X and Z for that sketch. Otherwise you won't be able to select that geometry. So we're going to go to job and we're going to create a new job and we're going to do turning, mill turn. Okay, and it's a S60-105 op 1 for the lathe. And we're going to use a cylindrical feature, and we're going to select our cylinder to be the outside of the stock there. And we're going to scroll down as always, and we're going to set our origin first. So we're going to go by Z and X axis. So Z is going to be normal to the face here so that we can drill the endpoint. The goal is to just do one operation on the lathe and hopefully only one operation on the mill. Okay, so we've got that established, but we need to have the x-axis in the same plane as the sketch we're using. So it's defaulting in a different plane. So select the, if yours is in the same plane as your sketch, you're golden. Otherwise, pick on what would be in probably the y-axis in this sketch itself, and it'll snap your origin so that it's normal to this sketch. Now we can set our diameters. So we're going to go to our diameters, and our material is most likely going to be 1/4 inch. So if we take and put a bracket in 0.25 and we minus our finished diameter is 0.197, and we put another bracket and we divide that by 2, that gives us our stock offset of 26 thousandths per side. Now on the front side we're going to add on about 10 thousandths. Okay, that'll be enough to clear. On the back side again, let's add 2 like we normally do. Not 20, 2. Okay, and we're going to scroll down, and how much is held by the chuck. Now typically we've been going, okay, we're going to have 1.6 of the stock in the chuck. We're not clamping from the inside. Our origin is going to be on model front. Program name is 105.1 S60-105 op 1 for the lathe. Okay. Okay, we can accept that job. Now we're going to change the name of that job to match S60-105 op 1 for the lathe. Alrighty then. We're going to start off with a facing operation as typical. Now the facing operation will work fine off the model. It's the things that are profiling will have an issue with this interrupted cut. Okay, so we're going to go to turning. We're going to do a turning face. We're going to select tool 1 from our library. Okay, let's slow this down to 20 inches a minute. This is a pretty small part. Our geometry. We don't need to do anything unusual there. We're going to go to our diameters, and we're going to leave all of this at default, except for we're going to go past by 0.01. We want to go past center line. Then we're going to go to the next step. We're going to do wear compensation, and we're not going to leave any stock to leave. And we're going to go to the last tab, and as usual, I don't like the way the default rapids are and lead-ins for a facing tool. There's no reason to come in a diagonal for a facing tool. It'll just knock the answer out. Alright, so we're going to deselect the same as lead in, and we're going to come in at 90 and 0, which will have our lead in come in straight in from the outside, and then we're going to back off from our cut away from the part. Alright, we're going to accept that, and we should have our first operation there. We're going to go ahead and do our drilling off the face. So we're going to go to drilling, and we're going to select from our library our spot drill. Remember, you got to pull it from the lathe library. And we're going to slow these lead-ins down. We should have set those lower in the tool library. We're going to leave the rest at default. Let's go to geometry. What are we cutting? We're cutting this hole. Okay, and we're going to go to the next tab and set our heights. Okay, so instead of going from stock top, we're going to go from model top, because we've already milled off the face there. And then we're going to go from hole top, and we're not going to go to hole bottom. What we're going to do is go from hole top. Remember, this is a spot drill, so we're going to put a little chamfer on here with it. So we need to override the depths that are in the model. Okay, so we're going to go from top of hole, and we're going to go a negative distance that's 10 thousandths bigger than the diameter of our hole. So the largest that hole can be according to our drawing is 0.099. So we're going to go 0.099 plus 0.01, in brackets, and we're going to divide that by 2. And it should give us 54 thousandths 510. There we go. So we got our countersink. It's going to be a little bit bigger than the hole, and add our lead in chamfer there. Now this hole is for a part to be soldered in. If we look at the next level of the process, so we're going to go towards the higher end of the tolerance on it. It's just going to get filled with solder. Doesn't need a specific press fit. So we need to select our drill from our list and go to our library, lathe tools, and we should be using the 98 thousandths drill or number 40 drill. Okay, so we're going to select that. Yeah, 5 thousandths fine. It looks like our plunge and feed rates are okay. We're going to go to which hole we're going to do? Same one. We're going to go to heights. Again, we're going to go from model top instead of stock top because we've already machined the stock down. And then we're going to go from hole top to hole bottom, which is fine. We're going to drill through with the tip. And that'll make sure that it forms a full tip. Now we don't want to go any farther because look how close the green line ends. We don't want it to break through into here, into the flats. Okay, so then our next tab, we're going to do a deep drilling. It just works better in softer materials, even though you're not going that deep. And our peck, we're going to go, let's go half a diameter, so 0.099 divided by 2. Actually, it's 98, but we're splitting hairs at that point. So we're going to do 49 thousandths pecks. It's not going very deep, so it's only going to do a few pecks. And we'll accept that. Alright, so we've got our drill. Now we just need to profile the outside diameter and trim it off with the parting tool, and we're done with the lathe operation. Alright, so let's turn the outside, and we want to turn it beyond, like we've done before, for our parting tool, but we're going to go a little bit farther because we're going to leave some extra material on the edge so that we can account for any tolerance difference in setup. So we know we have enough material to remove for the end mill that's going to cut this arc on the face. Let's go to turning. We're going to turn profile. Okay, we're going to go to our library and we're going to select our turning tool from our lathe tool library, which is tool number 3. Okay, I think we can leave everything at default. We're going to go to confinement and we're going to select under this model section. You're going to highlight just the 2 segments that make up the profile. Okay, so what we want to do is cut from here to here just at the outside diameter. And we're going to leave these other boxes checked at default. And what this will allow us to do is it basically ignores the model and just uses that profile. Otherwise it's going to error out on these pockets here. Okay, and then under confinement, we want to shoot past the part enough that our parting tool can come off and start at the model diameter. Okay, so we're going to go leave 0 in the front facing and back facing. We're going to go 0.2. Okay, we typically have been going 180 thousandths. We're going 200 because we're going to leave about 20 thousandths of stock on the back face. Okay, we're going to go to diameters. Okay, we're going from stock OD, and then we're going to go to the model outside diameter OD. We're not cutting all the way to the center. And we're going to leave those at default. We'll go to the next tab. We're not going to allow grooving because we don't want it to cut this curve. We just want it to cut straight. Okay, and we're going to go a roughing pass .04 is fine, but our finished pass is going to be .01. And we want to use wear compensation. We're going to go to the next tab. Now on this, our lead ends, we want to lead in straight here and lead out straight, and that way we get a nice profile there. So we want to lead out at a 45. Okay, so we don't want to have it the lead in is the same as the lead out, but we do want to set this at 0 for our lead in. Our lead out at 90. And that'll make sure we don't get any closer to the chuck than we have to. Okay, so one more lathe operation and we're done with the lathe, with the turning portion of the part. So next operation, we're going to go turning, and we're going to do a turning part. And we're going to select our tool number 1, which we've used before. And we'll again slow this one down. It's a pretty small part. We don't want to go 40 inches a minute. On a larger part, you might be okay. A little more robust. It's not going to flex out of the way. On confinement, we're going to leave it alone. We're going to go to diameters. And because we've already turned this down to model diameter, we're going to go to change this to model OD. And change this to model OD. And then model ID is fine, but we're going to go 0.01 deeper just to make sure we go past center, and that'll make sure our bar is nice and clean for the next part. Alright, now we're going to go to the next tab, and we're going to select wear. Check wear, then we're going to check stock to leave, and we're going to leave 0.02 of stock on the back side so that we have some material for error margin in our next fixture. We go to the next tab, linking. There's nothing to change there. We'll hit accept. Alright, so we've got everything we need here completed, and now we're ready to move on with the milling operation. The milling operation, we're going to actually be flipping the orientation of the part, and we'll be holding on to the side that has a drill point in so that we can do the machining on the flats, the end, and drill a cross hole. Okay, here we go. We're on to doing the next operation, which is a milling operation. So we're just going to create a new job. And this time we're going to select milling. And it's going to be S60-105 op 2 for the mill. That way we know in the program. And we're not using a relative size box, we're using a cylinder. We're going to select what our cylinder orientation is by selecting on the stock itself. And now we need to set our origin. Again, I always skip ahead and then move back to the stock because plugging in numbers there is meaningless until you have your orientation correct. We're going to do Z and X axis. We'll use the flat as our x-axis, or flat as our z-axis orientation, and it looks like X is already pointed the way we want it. Now you could approach this a lot of different ways. This side's already finished off to size and all the tolerances come from it. So for this example, I'm going to use the back of the part as the origin. There's a lot of different ways to fixture this. Okay, so I'm going to leave the x-axis where it's pointed. And we're going to go with a stock box point. And it's stock box point middle side 4. Okay, and that puts the origin on the back. So if we held this in what's called a collet, there's a tool that goes inside a collet called a collet stop, which will allow you to register the part, and you would be gripping on the diameter here, and the stop would hit this face, or I guess I could hit the bottom of the hole, but being that all the dimensions come off of this edge, you would want to use that as your registration point. Alright, and we're going to scroll back up. We're continuing from the previous job with our stock, and we are going to have an extra 20 thousandths on this face. So our radial stock offset is 0 because it's milled down. 0.02. We've got everything from the top. Now we're going to scroll down to the program name, which is going to be 1052, second operation. And it's S60-105 Op2 for the mill. We're going to accept that job. And now let's change the job name. S60-105 Op2 for the mill.